Good morning, and welcome to the CIECAst broadcast of Inside the AI Box, Black Box, Understanding How Algorithms Appraise Auto Damage in Seconds. I'm Ed Weidman, Executive Director of CIECA. Today's webinar will be presented by a team from Tractable. They will discuss artificial intelligence, algorithms, and how they can be used for vehicle damage estimating. This webinar does not allow verbal communication between participants and the presenters. If you have questions during the webinar, please type them in the webinar navigation pane on your screen. We will answer as many questions as possible at the end of the presentation. Now let's begin.
Excellent. Thank you, Ed, and congratulations on your new role at CIECA. Hi, everyone. My name is Julie Capitz, and I lead the North America business for Tractable. Tractable is an AI company focused on accident and disaster recovery. We were founded 5 years ago by a number of prize-winning researchers from top artificial intelligence labs, places like Oxford and Cambridge. For the last 5 years, we have been laser-focused on developing artificial intelligence for the task of auto damage appraisal. We've deployed this AI in 9 markets across North America, Europe, and Asia, and we've processed over $1 billion in claims. Today, having deployed this AI at scale globally, we'd like to talk to you a bit about what this technology is and how it can be used specifically for auto estimating. I'll let our team introduce themselves.
Thank you, Julie. My name is Marcel. Hi, all. I'm leading the estimating product team at Tractable. My background is in quantum physics research, and so I'm really heavily leaning towards the research side on developing the AI, but I'm also working on bringing this amazing technology to build amazing products and bringing it out to the real world to make it useful. And I'm really excited to talk about this today.
Hello, everyone. My name is Lisa Monzon, and I am Tractable's auto appraisal expert. Prior to Tractable, I spent 15 years in the U.S. auto insurance industry with carriers such as Progressive and Travelers Insurance.
Great. Let's dive in. We'll do a few things today. We'll start with a brief introduction to computer vision. We'll then talk about how this technology is applied specifically to the task of appraising auto damage. After that, we'll give you a hands-on feel for what this means. We'll give you a live demo of this AI. And we'll follow up by talking about what it means to deploy this AI in the real world and truly capture value.
Sounds great. So then let's start with introducing a few key concepts that we're going to revisit a couple of times today. The first one is AI, artificial intelligence. What does that mean? AI describes machines and computer systems that exhibit cognitive functions that are on par with humans or even surpass human performance. That's the first one. Then what we're really focusing on today are systems, a type of AI systems that are focused on computer vision. So they are focused on making sense of what is the content visible in photos, what things can be reasoned about in the photos. So that computer vision describes systems that allow to perform this task. The task of computer vision is a really challenging one because we have typically a photo contains millions of different pixels, which means different values of brightness and color intensity. So it's really challenging for a machine to make sense of this. A key technological breakthrough that has happened over the last few years is called deep learning. And this breakthrough allows for machines to learn computer vision tasks effectively. And this means both that it can perform computer vision tasks at or even beyond human accuracy, and also it now is feasible to build these systems. It's still challenging, but it's feasible to build such systems. Having said that, I would like to introduce a little bit how does this work in practice, give an idea of how these systems work, how they perform, how they operate. To explain this, I thought we'd start with an example which is not about cars, but which is about food. So I have 2 examples here of 2 dishes. On the left side, we have a pepperoni pizza, photo of a pepperoni pizza. And on the right side, we have a Bavarian Weißwurst meal. So I'm from Germany. I thought I'd take the freedom to pick something German here. And we're going to now look at how does a AI computer vision system, how does it go about looking at these photos and making a decision of what type of food, what type of dish are we looking at here. What you can see here is again, we have on the left side of these two photos of these two dishes, and in the middle, a rough depiction setup on how a deep learning system operates. It's simplified, but it will give you a good idea of how they work, what the main concepts are. So if we look at the pepperoni pizza photo, for us, if you look at that as a human, we can identify a couple of really distinguishing features. We can see, for example, these pepperoni slices, which are these red circular things which are really distinctive. We can also see maybe the cheese and the pizza bread and other things. If we look at the Weißwurst meal, we can also see some really characteristic features like the pretzel, the sausage. Now, the deep learning computer vision system will also identify in a first step individual important elements like the pepperoni slice and the pretzel, and identify that they are somewhere there in the image. Now, to form the full assessment of what dish are we looking at, it will combine the information about individual elements, about the presence of the individual elements, into the full decision, such that the pepperoni pizza will be a combination of pepperoni slice, pizza cheese, and pizza bread. Okay. So if we look at this again at a higher level, we can see that from the left, where we gave the computer as an input a photo, which is just like millions of pixel values, different bits and bytes, which just describe the brightness and the colors. We've taken this really unstructured and large amounts of data to make a few high-level insights and decisions about this photo. That is, and it shows the dish pepperoni pizza or Weißwurst meal. So we think that's really impressive. And if we go beyond food and look about how can this be applied to other tasks, there is a standardized computer vision challenge, which for a long time has been really hard to perform for computers. So if you look 1 decade back, a typical computer vision system had an accuracy of 70 to 75% on this task, on this challenge. Humans were at 95%. What happened over the last few years is there has been rapid progress on these deep learning-based computer vision systems, such that in about the year 2014, 2015, computers, for the first time ever, have surpassed humans at the ability to distinguish what type of thing we are looking at in a photo, at the ability to reason about visual content in photos. And we think this is a really impressive accomplishment that has happened. And this is something that we are really excited about, to bring this impressive breakthrough, bring that to the task of car damage appraisal. With that, we come to the next section of our webinar, and that is, how do these computer vision algorithms, how do they appraise auto damage? We're going to start now with a relatively simple example, or like this relatively simple first step. And that is, given a photo of a car, what part of the car are we looking at? Are we looking at the front, at the back? Are we looking at the trunk lid, the hood? First of all, why is this important? The reason why it's important is because the repair methodologies and the decisions on whether we need to repair or replace a part really depend on what type of part are we looking at. A fender is much easier to replace than a quarter panel. Our computer vision system will need to take this into account. If you look at this photo now, concretely, we can see we have a car in focus, but also there are a lot of elements that can be a distraction. So it's on a parking lot, there are cars in the back, we have reflections on all of these surfaces. None of these can deter our algorithm. And now we can try to understand again, how does our algorithm identify that we're looking here at the rear right corner of this vehicle? And similar to the example of the pepperoni pizza, here as well, we have a few characteristic features about this viewing angle on the car. The first one, which is really obvious, is the red taillight. It both has a typically characteristic shape, although there's a bit variation, and is red. There's one feature that our deep learning system will pick up on. So if we look into the system, somewhere in this computer vision system, there will be a part that has learned to identify red taillights. Another important feature can be the rear-facing mirror on the right side here, which also makes it very clear that we're looking at the rear right side, or a tailpipe. Now, again, the presence of these individual elements will then be used by the computer vision systems at a higher level to reason about what angle of the car are we looking at, what viewing angle are we looking at the car, and what parts are visible. So in this case, the assessment would be, we're looking at the rear right corner. It's a rear right corner shot. We can see the trunk lid, we can see the right tail lamp, rear bumper, and the right quarter panel. And this is again an assessment of maybe 5 concrete outputs that we're getting here from an input, unstructured input of millions of different brightness values, color values, and with all these other instructions that you can see in the photo. Another thing that's important to highlight here is this is also a task that needs to work reliably on different shapes of cars. So this needs to work on a pickup truck, a station wagon, on a hatchback, on a saloon. Now, let's move on to a more challenging task, and that is assessing damage. Not only localizing damage, but assessing it. We're going to pick an example of a damaged rear right door, where we can see, highlighted with the square box, there's a dent in there. It also just crosses the body line, so it's also quite hard to repair. And in a similar way to our previous examples, on the first level, the computer vision system will identify individual features of damage, which in this case is a dent. It could also be a scratch, or it could be a different type of dent. It could be a larger dent, which may be not next to close to a body line, and so on. And it will then take these individually identified pieces of damage and come to a conclusion of how long will it overall take to repair this panel. So if we again look at the overall, at the slide, we can see the AI has started with an input image where we can see both a rear right door, also some other elements of the car, which it has to learn not to focus on. So we have to ignore, in this case, the damage to the quarter panel we can see here, and then quantify how long will it take to repair this. And this is what is happening here. Now with this, we already have looked at a few ingredients that we need to assess car damage. If we want to go to a full repair estimate, there are more things we need. We've now looked at the visual input, but there is also a non-visual input that is required to write a full repair estimate, something that we are doing every day and something that we want to do. Other ingredients are, we need part prices. For parts that we have decided that need replacement, we need to know how expensive will those be. For some parts, there may be a difference in material type. So there may be a plastic version of a bumper, there may be a steel version, and those will have different standards of repair, different possibilities to repair it. That's another example. Or something really important, repair methodology. Let's say the AI has figured out that we have to replace a door. We also have to follow safe instructions on how to replace this door. So what other elements may have to be removed before this door can be replaced. For all these other non-visual types of data, we're working worldwide with multiple data suppliers that give us access to this data. Just one possible example that I can talk about here is Touchdown Research. They're performing independent research on how can a car safely be repaired, both safely and effectively. And that's one of our global partners for these times. Now with this, we can move on to one of the other assessment tasks that are required to write a full repair estimate, which requires a combination of both visual and non-visual input. And that is the question of, do we need a blend, do we need to perform a blend operation on a certain pattern? What we have here prepared on the slide are two examples of two cars which both have an impact to the left side, so both doors are damaged. The question that we're trying to answer is, do we have to perform a blend operation on the front left fender? If we look at it, how does the AI go about making this decision? It will again start with identifying individual features of damage, which in the upper example, there's a dent. In the lower example, there are a lot of scratches in there, but then also combine that information with what are the specific rules for this country, for this insurer, how blends should be performed. And that together will allow an assessment to be made on, in the upper case, we do not have to blend this fender. In the lower case, we do have to blend it. So if we take a step back here, I hope we have now looked at the breadth of different computer vision tasks that we can all perform. We can all perform quickly. We can all perform on a variety of different cars that together allow to write a full repair estimate.
Great, thank you, Marcel. I hope that gives all of you a brief introduction to how this technology works. Now that we've looked under the hood of how an AI works and how it appraises damage, we'll actually take it for a ride. So we'll do a live demo. As Marcel mentioned, typically products like this have a combination of visual reasoning and non-visual inputs. Today, we will demo specifically the AI part. So the visual reasoning that image classification algorithms undertake from individual photos. And what's important here is that we will do this with unseen examples. Whenever someone offers to show you an AI, it's very important to show unseen examples to the AI, so examples that the AI has never encountered, to make sure that AI can perform in a robust manner across a variety of cases. To do that, we'll actually just find photos of damaged cars on Google. So I'll pull up an interface for our classifiers here. And I'll pull up Google Images as well. Okay. And now I'll do an example first, just so everyone sees how this works. And then Ed, I will ask for your help to pick images so everyone can make sure that these are actually random, things that the AI has never seen. So let's start with a damaged car. Okay, we can pick any of these and put them into the AI. For example, this one. As you can see, this is a car in the parking lot, pretty severe damage, some glare here, strange shadows. We can put it in and see what happens. As you can see, this photo in seconds went up to our classifiers in the cloud. Those classifiers, these classification algorithms, very rapidly made certain assessments on the single photo. So they looked at what are the visible parts. They saw the hood, the right headlamp, grille, left headlamp, bumper, right fender, all these things here in the front. And they also classified whether these are likely repair or replace operations. So as you can see here, clearly with this level of significant damage, the AI is quite confident that all of these parts need to be replaced. Now this is a single photo. An AI product would take all the photos in a given claim or for a given vehicle, have these decisions for each photo, and then aggregate or pool them to come to a set of conclusions, and then add non-visual inputs as well. So Ed, for the next one, maybe you can help me choose.
Let's go with the silver car on the bottom left.
This one right here?
Yes.
Okay. This one is also interesting, clearly outside as well, some shrubbery in the background. There's a reflection on the hood, different lighting conditions as well. Very unstructured visual input. As Marcel mentioned, the AI sees this as millions of pixels with different color or brightness values. And it needs to make sense of these millions of pixels to understand what parts are visible and whether they need to be repaired or replaced. So let's put this in. And actually, before we discuss what the AI thinks, Lisa, I'd love your help to make an expert appraisal of this as well. So you've spent over a decade in the industry. As an appraiser, how would you look at this car?
Sure, Julie. So looking at this car, what clearly stands out, first off, we have a nice little impact to the left front corner. And so what I see, first off, we have a front bumper that is torn in several areas. We also have a headlamp where the lens is missing, it's cracked. And we also see some significant damage to the front of the left fender. We have a great depression on the front part. We also have, we can see where it's kind of folded back in a sense. So as an appraiser, if this were something that I would see in the field, the front bumper, left headlamp, and the left fender would require replacement.
Thanks for that, Lisa. It looks like the AI agrees with you. So off this one photo, it has picked up the fender and it's very confident that this needs to be replaced. Same thing with the front bumper and same thing with the headlamp. The grille, the left front door, and the hood, it's feeling pretty good about it. It's saying they're intact, or maybe there's some minor work that needs to be done. So very quickly, the AI came to the same conclusions. So Ed, I'll actually, looking at these photos, they're all pretty mangled cars. Why don't we look for something less obvious? So let's look for maybe minor car damage. These look to be more minor dents, maybe scratches. What do you think? Any of these you'd like to try?
I'll scroll down a little bit. Oh, why don't we go with the one that's the silver that you have your mouse over now?
Let's see, which one is that?
Second row, third from the left.
This one, right here?
Yes.
Let's see. Well, this one is interesting. So this one actually is a white car, which is going to be difficult for the AI. It's difficult for humans as well. And it's actually a stock photo, which is potentially tricky. Let's see if there's a non-stock image here. Why don't we pick something that looks a bit more like a claim photo? I think these watermarks are actually not quite representative.
Okay. How about the door?
This one right here. Okay. So again, another white car, something quite difficult for a human as well as an AI. I think any appraisers in the audience will know that photos of white cars are tricky because the contrast is quite difficult to pick up. This is also a close-up, so the AI has fairly limited context. It doesn't see the rest of the car. It just has this one white mass to look at. So let's see what happens. Lisa, what do you think?
So here, looking at this photo, the front panel is likely the right front door. We have some cosmetic scratches that are across the door. And also looking to the rear, there seems to be a small little indentation as well. But if this were the photo that I would be assessing from, I would write for the panel to be repaired, the front door to be repaired.
Interesting. So the AI is trying to make sense of this close-up photo. It picks up that this is indeed a front door. It's quite confident that it is a door, probably because the handle is here. It thinks that it likely is repairable. It's about 80% confident. But typically, it would look for other photos in the claim to get to a higher confidence level. On the back door, down below here, you can see it thinks there might be a rear door in the photo as well, but it's only 32% confident. So it would want more photos to make a repair, replace, or repair assessment. So here, it's asking for more photos, essentially, and it would look for the others as well. Ed, how about another?
You know, we got a request to try a damaged car with lots of reflection.
Damaged car with lots of reflection. Okay, sure. Let's see. Do you see any with lots of reflection here?
Let's go back.
Oh, maybe this one?
That's fine.
I'll let you pick.
Well, we did have one with here. Why don't we? How about the silver one on the right side, all the way on the right side?
This one right here?
Yeah.
Okay. So indeed, a lot of reflection here. So the AI will need to make sense of that, as you can imagine. Given that these are just pixel values to the AI, that's not that straightforward. It's a top angle as well. It's a pretty sharp angle here with pretty bright glare on the front. Let's put it in.
We also got a request that said try some highly zoomed images. So there's one right there on the right side that looks to be zoomed, and why don't we take that bumper? Would that be something, or?
Sure. Which one do you mean? This one up here?
In the black part on the right side.
This one? Minor clip,
yeah.
Make image? Sure. Shall we do the reflection first, or do you want to jump to the bumper?
I'll do this reflection first, and then we can go ahead and do a zoom in.
All right. So it's giving it some thought. Clearly the reflection.
Typically what's happening here is this may be a photo that is in some way corrupted or has a weird format.
Interesting.
Maybe we could just reload.
Yeah, let's try to reload. Shall we try the bumper instead? What do you think? All right, let's try the bumper. So close indeed. Let's see what happens with this one. Lisa, would you like to share your thoughts?
Sure. So looking here, we have damage to the front bumper. We see that the corner has a large depression through it. There's also damage through the body line. Not to say that damage of this nature can't be repaired, but just looking at the dent itself, how it's kind of moved over to the little bezel that's below, I'm leaning more towards replacement of this front bumper cover based on the damages.
Okay, very interesting. So the AI here is also picking up on the bumper. It agrees that it's a replace, but again, given that this is a close-up, it's about 72% confident. So it is looking for other images of the bumper to make a fully confident assessment. And then it would aggregate its assessments across those photos to come to that full conclusion. And maybe we can find another photo of something with a reflection, maybe a photo that's not corrupted.
Oh, that red one. How about the red one there?
Let's see. This one is interesting. Certainly a reflection here. A close-up and a reflection, so that fulfills both requests. Let's see what happens. Lisa, what are your thoughts?
So my thoughts initially, this looks likely to be the left rear door and possibly the left quarter panel. We have just some minor damage, some scratches through, and they certainly look repairable, Julie.
Yeah, the AI is picking up on the quarter panel as well. On the door, again, it thinks there might be a door on here, but it's still looking for more photos. So it's still trying to make sense of this given the close-up, but it has a starting point, just looking for more. Okay, looking at time, Ed, how about maybe one or two more? Or if there are other requests from the audience, we can take those as well.
Can we see a multiple photo estimates?
Multiple photo estimate. Good question. So I think for today, given the topic of the webinar, we very much wanted to focus on the visual part of a system like this, specifically the computer vision or image classification at play. We certainly, maybe in another session, would be happy to demo an end-to-end technology that combines these visual inputs with non-visual inputs as well. But today we'll focus just on the visual part.
Okay, now we got a request for the yellow one.
The yellow one, okay. So interesting as well. This one is very close, which I think might be tough. Again, just one photo, so the AI has no other context. Let's see what happens. Okay, so this one again is quite tough given that there is no other context. Usually this is something that would be seen by the AI in a batch of photos. Actually, Lisa, as a human, can you tell what part of the car this is?
It's funny that you say that, Julie, because to be quite honest, I'm not sure if it's the left quarter panel and back bumper or the front bumper and the right fender.
You know, the AI is thinking the same thing. I'm saying there might be a fender here, maybe there's something else. Again, it's looking for that additional context. So it's having the same troubles as a human appraiser, because of course it has been taught to reason like one. How about something that is maybe more visible to a human, Ed?
Well, we got a request coming in saying show a demo on a car having a missing headlight.
Sorry, a demo on a car with a missing headlight, you said?
That's what it says.
Okay. Let's see if any of these are missing headlights. This one is a broken headlight. Maybe we can Google for it. So let's see. Any here that appeal to you? These are, it's strange. Most of them are just headlights, I think. How about?
It looks like we may not find it. How about a vehicle with structural damage or any part missing?
Any part missing.
Or structural damage. I think the main thing is structural damage.
Interesting. So I think the AI is primarily looking at the outside of the car in this particular demo. So maybe we focus on that. Let's see, what if we go back to some of the banged up cars we saw originally?
All right, I'll let you try to find one either with structural damage, and we've got another one that says windshield damage. I think one of them did have windshield damage that I saw.
I think we at least found one with a missing headlight. Should we try that one? This one looks okay. I'm sure there's something structural in here as well. Okay, Lisa, can you talk us through?
Sure. We have another impact to the left front side of this vehicle. As someone had requested, the left headlamp's clearly not here in this photo, or that, or it's like pushed back into the radiator support area. So clearly this would need to be replaced. Also, we have another mangled left fender, which is mangled pretty much throughout the entire panel, which would be another replace. Also, we have a bumper that has what looks to be mainly cosmetic damage to the outer edge. But what's also intriguing to point out is the tab area just above where the cosmetic damage is attaches to the left part of the fender, the left part of the front fender. And so just looking at this photo, as if I were writing it, I would definitely lean more towards replacement because of that, even though we can only see mainly cosmetic damage on the outer part of the bumper. Julie.
Thanks for that. That's really interesting. So here, looking at the headlamp, which is I think what the request was for, there clearly is no headlamp left, and the AI is indeed picking up on that. So this AI is trained on millions of historical examples, millions of photos. So among those, it has seen enough cases of damage like this, so cases of entirely missing lights, that it knows to pick this up, even though this does not look like a glass headlamp. What does it mean to deploy it in the real world? Well, whether you are working for an insurance carrier, a car repairer, a parts provider, a salvage player, or anyone else in the collision repair industry, this might be of interest to you. Because as you think about where this technology applies in the claims and repair workflow, it can really apply anywhere where you have human experts making expert visual decisions. So looking at vehicles or photos of vehicles and coming to conclusions based on what they see. 3 specific use cases that we've seen in practice. One is total loss triage. I think as many of you know, traditionally, total losses are identified in the industry at first notice of loss through a series of questions. Questions like, has the airbag deployed? Are there fluids leaking? Has the car traveled on its roof? These questions are a proxy for damage, but they're not an actual assessment of damage. They're our best guess at whether a car is actually totaled. Well, this AI can significantly improve on the performance of questions like that by actually providing a visual assessment to identify total loss in seconds. Another use case that is of interest, I'm sure, to this group is photo estimating. So having a tool that goes from photos to an estimate in seconds. This can, of course, eliminate an appraisal appointment for a consumer. It can save time for the insurer. It can save time for the repairer as well. It's a highly impactful use case. Now, if estimates are already being written, be it in-house or by a third-party independent appraiser, this AI can also be used to audit those estimates. In that case, the AI takes an estimate that has been written, it takes the photos and compares the two to make sure the estimate is as accurate as possible. What does this all mean for a business? Where's the value? Well, if you look at this technology, we typically see value in a few different buckets. One is much greater accuracy and transparency. I think as many folks on the phone know, appraisal is as much art as it is science. Humans are inherently subjective on this task. So you'll see differences across regions, across methods of inspection, even across the decisions of a single appraiser on different days or in different months. The incredible thing about algorithms is that they are deeply consistent. So you show the same car to the same algorithm day in and day out, and it will give you the same decision. As a result, you get much more accurate appraisals, much safer repairs. Of course, another benefit of this type of AI is automation and efficiency. If you think about how long it takes a human appraiser to look at a vehicle, it could be 30, even 45 minutes, depending on the extent of the damage. Conversely, as you've seen here, algorithms can do this task in mere seconds. It's a significant difference. In practice, what that means is that algorithms can handle some of the easier cases, for example, and human experts can focus on the much more interesting, complex cases at play. Overall, what does that add up to? It adds up to a much better customer experience. Customers who can get back on the road more safely and more quickly and be much happier with their service providers. That's everything on our end. Maybe we jump to Q&A next.
Okay, we do have a few questions. The first one that I think we need to answer is, what happens if the photo has 2 cars visual? How does the application handle that?
Excellent question. So the AI, in that case, has to indeed discern which car is relevant. And it has actually learned to do this. I'm not sure if we saw it in the examples here, but among the millions of photos it has seen in its training set, there are many photos at salvage yards, for example, that have rows and rows of vehicles. So it actually figures out which one it's supposed to be looking at. Maxwell, maybe you can tell us from a technical perspective how it has learned that.
That's a really good point. And it has learned that in a similar way as we talked about before. It will have learned what is the relevant thing that we're looking at here. What is characteristic about the car that is in focus of the photo. And it will then have learned how to pick up on that. And it will also, will have done this in a reliable way.
Okay, next question. What about images under the hood? Does your application do anything with that?
Great question. So the technology that you saw, the demo that you saw, is currently focused on external damage. However, as you saw in Marcel's example, it has learned to pick up instances of internal, non-directly visible damage from the external panels. So it actually gains an initial estimate or prediction of things under the hood from what it sees on the outside.
Next question is, well, let's first take the one is, when do you feel that it'll be available for general appraisal use?
Sorry, was the question, when will this be available for general appraisal use?
That's correct.
Is that right? So on our end, we didn't talk too much specifically about Tractable's product suite. We have deployed this technology. It's deployed, as I mentioned, in 9 different markets across use cases, some of which are to write estimates. So for that type of appraisal, if that's the question, some of those deployments are to audit estimates. Some of them are to identify total losses or triage claims as they come in. So this is indeed live.
Okay. Can your system determine structural damage? Does structural damage exist?
That's a very good question. Our systems can indeed identify the presence of structural damage, and then we use this to triage claims in certain directions. So is it an obvious total loss? Does it have dangerous structural damage? These type of things. So this is indeed something that is supported by our systems.
Okay. Does your system know what the part is made out of? For example, carbon fiber, aluminum?
That's a really good question as well. And here the answer is, it's a combination of cases in which our system can determine the type of material from the photo, if that's obvious. That's possible for things like if you have a crack in a plastic bumper, that's obvious that it's plastic. And also we can see that something from bumper, a component may be made out of chrome, that can be determined directly. And there will be other examples in which we need the input from the non-visual side. So this may be questions like, is it made out of aluminum or out of steel? That may be hard to tell in certain cases.
So for example, one of the non-visual inputs we take is the VIN. From that we decode whatever a VIN can tell us about year, make, model of the car, potential trim levels, if those are included in the VIN there. What you've seen here are just the visual inputs. These are pure image classifiers that are agnostic to year, make, model. So everything you saw today being demoed, the algorithms had no idea what cars they were looking at. They would just have these millions of pixels in a given photo. Inputs like the VIN help our products refine the appraisal by layering on that type of information. By the way, the component of year, make, model universality, so having algorithms that are agnostic to year, make, model is very important, because you have new cars coming out every year, hundreds of cars. So if you're just trying to, for example, train a system for a specific year, make, model, you'll need to train hundreds of systems every year. It's just not feasible. So that is one reason we focus very much on the difficult but now achieved task of building visual models that don't consider the year, make, model as they assess photos.
I've got a question. What pooling technology is being used in the demo?
pooling. Can you repeat the question? Maybe let me confirm my understanding. The question is, what pooling technology was used?
Yeah, that doesn't make any sense to you?
There are multiple ways in which we could talk about pooling, but I'm not sure I can. I think it would go beyond the scope to explain this. There are multiple ways in which pooling is used in these technologies, and that gets really complex, so I don't think we can answer that here.
I'm impressed with the question, actually.
Yes.
I think we have time for one more question here. Do you use estimating platforms, or did you build an estimate within your proprietary system?
That's a really good question. We are building our own estimates. So we are building them from scratch, and we have talked about all the required input data, and that's an estimate that is generated by our computer vision systems, AI, fully automatically.
If you think about what an estimatics platform is for, it is to facilitate the workflow of a manual estimate written by a human. Here you have an AI automatically producing an estimate, so you don't need the human workflow. The estimatics platform here is essentially irrelevant.
Okay. All right. Okay,
So
I think
at that point.
Go ahead.
What was that?
All right, I think that's about as much time as we have in order for the questions and answers. I appreciate that.
Great. So then on our end, we'll just thank the audience for dialing in. If you have additional questions, and it sounds like there might be a few that come up in the coming days, feel free to reach out. You could find us at a webinar at Tractable.ai, also on LinkedIn and Twitter. And I will then hand it back to you.
Great. Hey, this concludes today's CIECAst. Our next CIECAst will be held on October 15th. Susanna Gosh from CCC will be presenting in that CIECAst. You can find the full schedule of future broadcasts on CIECA's website, CIECA.com, using the events tag at the top of the page. Also available on the tab is information regarding CIECA's Connects Symposium. Please join us at the 2019 CIECA Connects Conference in Charlottesville, Virginia, September 16 through the 18th. We have a full agenda of both business and technical presentations, which include blockchain, cybersecurity, OEM repair information, and calibration. Just prior to the conference, there will be a tour of the Insurance Institute of Highway Safety facility and a viewing of a live crash test. Registration is available on CIECAconnex.com. CIECA has partnered with the Automotive Management Institute, AMI. Attendees of this webinar can take a short quiz on the AMI website and earn credit toward a professional designation. A link to AMI and a coupon code is available on CIECA.com. Please follow CIECA's social media platforms to stay up to date on upcoming events and CIECA news. Thank you very much. This ends today's webinar.
Thank you, everyone.